In this lesson, you'll learn how to apply one of the laws of exponents, simplify exponential expressions using that law, and write an equivalent expression. Let's go ahead and get started. If we look at this first problem, 5 squared, and I wanted to multiply it by 5 to the 4th power, how could I write an equivalent expression? Well, I noticed the first thing is that my base is the same. But what would this look like? Well, I know that I have 5 multiplied times self 2 times here, and in here I have 5 multiplied times self 4 times here. And if I were to write this out, it would look a little bit like this. Now notice this is not time efficient. This is 2 times here, and then multiplied, and then I'm going to have this 4 times here. It would take you quite some time, and so that's why we have these laws of exponents that allow us to manipulate these expressions in a way that's going to do this a lot faster for us. So if I were to count these out all together, I have 1, 2, 3, 4, 5, 6 5s. Basically, one of the things that you might notice is that our exponents give us all the information that we need. So if we have 5 multiplied by itself twice, 5 multiplied by itself 4 times here, then we can simply just do 5 and add our exponents. That's going to give us the same answer as 5 to the power of 6, and we don't have to write any of this down. So let's go ahead and try to apply that law in the next problem. We have negative 2/3 raised to the power of 4, and we have the same base here, negative 2/3 raised to the power of 5. And so if I apply this law of exponent that I just learned, my base, because it's the same, negative 2/3, what I'm going to go ahead and do is I'm going to go ahead and grab these exponents and add them. So we have 4 plus 5, and that gives me an equivalent expression of negative 2/3 to the 9th power. If I were to have x raised to the power of m, even though I don't know what m is, times x to the power of n, and I don't know what n is, but I know that it's different than m because they're a different variable. As long as I have the same base, which I do in this case, I can apply the law. So my final result would be m plus n. And this is as far as you could simplify it. I can't simplify it anymore without knowing what m or n is. So I'm just going to go ahead and leave this. I have 2x raised to the power of 2 times 5x cubed. So a couple of things that you may notice here. The first thing you may notice is that there's this number. There's this coefficient right in front of the x variable. Now, when you're dealing with the law of exponents, they're really only good if you have the same base. If you have a different base, you can't really simplify it. So that's an important thing to remember. What I do notice is that I have the same base with x here. So for now, I'm just going to grab these coefficients and multiply them. And then I'm going to grab my exponent, my variables that have the same base, which is x. And because the parentheses are on the outside of the expression, they're being used right now to group these expressions together. My exponent belongs to this variable. So my exponent here is a 2, and my exponent here is a 3. I'm going to go ahead and add those together. I can't do the same with my coefficients though, because they're not the same. 2 and 5 are 2 different bases, and so the only thing for me to do here when it comes to simplifying this expression is multiply these coefficients, which is 2 times 5 is 10, and then go ahead and add the exponents for that x, which is 2 plus 3 makes a 5. Let's go ahead and try the next problem. In the next problem, we have just variables. We have a's, b's, and c's. So I know I'm not going to have a different variable. My variables are going to be a, b, and c. And I'm going to multiply it together. This law of exponents says that if I have the same base, and then I can simply add the exponents together. So in here, I have 2 a's. There really is an exponent here that you don't see, but we just don't usually write it. So I'm going to write it for today just so that you know where this came from. We have 2a's, and then we have an exponent of 2 here, and then an exponent of 3 here. So I'm going to go ahead and add those exponents. And lastly, I have an exponent of 3 for c and an exponent of 4 for c. So I'm going to go ahead and add those there. And if I were to simplify this even further, I would have a squared times b to the power of 5 times c to the power of 7.